Hello everyone and welcome back to Mathics. In this video, I'm going to go through question 1 to 25 as usual. And I have some more points to add. Number one is how to use this video effectively. See, when I make these videos, all I have on my mind is how to use this opportunity to help you improve your mathematics skills, right? So it's not just about I understood the question and I understood the solution. Thank you. No. When you watch the video, after you understood it, hopefully, go back to the beginning of that question and just see it one more time. Don't see it as a student. Okay, maybe see it as a teacher. See it like as the steps I took in order to find that solution and drive that solution. Okay, so the steps we make, if you have a general view of what's going on, it helps you with more similar questions, right? So don't be like, I understood the solution, bye bye. No, think about the steps that we take to find the solution, okay? So the second thing is you could support the channel. If you are a subscriber of the channel, you have already supported the channel. But if you want to take it one step forward, you could also become a member. So to become a member, you need to go to the front page of my channel and click on join. There will be three options. You could choose any of them that you want. So, and lastly, you could also book classes with me. Right now, they're only one-on-one classes. So, and I have my contact information. You could contact me through my email. I have my WeChat account, and I have Telegram, and a few more. So there'll be no problem to contact me. Okay. So hopefully I see you in the class. If you compare this question with a previous year's questions, I think this is really difficult to be problem one. And I'm sure a lot of students will subtract all the numbers. They waste 5 minutes and they're going to get it wrong. So, but it's actually a little tricky. And all we have to know is when we do subtraction, for example, I'm going to go 325 minus any number, 2, 2, 2. Okay, what is the ones digit like this one? We just do 5 minus 2, 3, right? This is what we always do. But we just have to notice that if I make this number 5, if I turn it into a 9, does the ones digit change? No. If I change this one into another 7, no. So all we have to do, and all we have to know, as long as we care about the ones digit, we shouldn't care about these digits here, right? We don't care about these, okay? We just care about the ones digit in each number. So, for example, now here, when I subtract these two, what is the ones digit? Don't care about these numbers. You just go, okay, 2 minus 2, 0. Okay, so 0. And then the units digit, we have a lot of numbers before this, but the units digit is 0. And then you're going to subtract it here. Again, these numbers are not important. You have to just assume what happens when I do 10 minus 2, for example. Or if you go, for example, 1, 0, 0, 0, 0, and then you have 2 here, you could have any number, 3, 4, 5, 9, who cares? As long as this is happening, the units digit will be 8, okay? So after we do up to here, the unit digit is 8, okay? And then we only care about these numbers. So 8 minus 2, so far it will be 6. You do it with another 2. 6 minus 2 is 4. And lastly, you have 4 minus 2, 2, okay? If you know this, and if you're quick enough, 20 seconds is enough for this problem, right? What is the value of this expression in decimal form? So what I hope is that when you just saw these numbers and you were like, all of them are divisible by 11. All of them are multiples of 11. Okay. So because of that happening, what is 44 divided by 11? 4 plus. This one, let's just go first divide both of them by 11. Okay, so what do we get? 110 divided by 11, okay, is only 10. Okay, so I'm going to write this one here. It's equal to 10. What is 44 divided by 11? 4. So this is 10 over 4. So, and here you could go on and divide it. You could divide them both by 2, and it will give you 5 over 2. So when we divide 5 by 2, what is the answer? 2.5. So I'm going to write a 2.5 here. And lastly, again, so we know that both of these are divisible by 11. So this one we divided by 11, 45 divided by 11 is actually 4. And this one divided by 11 is only 100. Should we simplify this? No, right? Because it's already perfect to be turned into a decimal point. This is equal to 0.04. And now we're just gonna add all of these numbers together. 0.04. Okay. So still, I'm sure some students will make mistake at this part. So I'm gonna write it vertically. And the reason will be something like this. So 0.04, okay. 2.5, look, we're gonna have 2 and a 5. 2 is here, 0.5 will be below this, okay. So maybe you could add a 0 here if you like to, or just not add it. But remember, this is 2.5. And the last one, 4, is here. So it's gonna be 4, 0, 0. So if you write it like this, then we don't make mistakes. So it's going to be 4, it's going to be 5, and it's going to be 6. 6.54. The answer is C. This one, again, easy, but it's a little tricky. Okay, this problem 3, problem 11, and problem 22 are using the same idea, right? Problem 18 is the same as problem 3, a little more complex, and 22 also. And we have seen a lot of other AMC questions just using the same idea in different questions. So I'm just going to use this question as an opportunity to get familiar with this type of questions more so that we could just do it later on in all the tests that we see this idea. Okay, so let's go and learn more about it. Let me ask you this now. Do you know how to find the area of this shape? So probably you would be like, I don't know, there is no formula for this shape, right? Or maybe there is something that I haven't learned at school. Well, if you feel this way, I'm gonna ask you this. Do you know how to find the area of squares? And do you know how to find the area of circles? If you do know both of these, so the answer to this question is yes, you already know how to find the area of this shape. Okay, but why does it look so weird? Okay, because this shape is made of 2 different shapes being subtracted. See, the first shape is that this one is equal to, in order for me to draw this, what I did was first I drew a square. Okay, and then I minused it and I subtracted a part of it. Can you just tell me, in order to get this shape, I need to remove what part of this, right? I need to cut away some part of it. Do you agree? In order for that one to be this, I need to cut away this part. And I'm gonna go, okay, this part is going to be out, right? If I cut this out, then this will be this, right? So, but what is this shape really? All I have to do is go, okay, I have a square and I'm going to minus it by, okay. So let me just go and show it to you. I'll just like how I pick a square like this. I pick a circle and I'm going to remove first this half, then a little less maybe, and this half. So this is what I did actually. Okay, so to draw this one, I drew a square and I just removed like a fourth of a circle from it. Then I get this shape. And for you to find this area, you have to do the same thing. Okay, so let's go back to the problem 3. The idea of problem 3 is the same thing. Okay, so it's gonna be, okay, I have a square and then I'm going to remove, okay, a smaller square from it. Like this is what they did. Okay, let me go like this. So when you see a shape like this, weird shapes like this, you have to think, oh, it's a problem of removing something, a shape I know, from another shape I know, but the combination looks weird, right? So for example, if somebody tells you to find the area of this, you say, it's made of 2 rectangles. Yes, but it's also 1 square minus another square. This one is 1 square minus a fourth of a circle. So, and again, we have seen different shapes in AMC8 previous years, okay? So there was one problem 25 that had a super weird shape. Okay, so now that we know this, okay, this is the idea of problem 3. Let's go and deal with problem 3, okay? Okay, now let's go and deal with problem 3. Okay, as you see, we have 4 squares of lengths 4, 7, 9, and 10. And what we really want, and the only thing we want, is the area of this part and this part, this gray region, this shaded region, plus this shaded region. And we find them, we add them, that would give us the answer. So I want you, when you see a question like this, to focus on different parts individually, right? So you ask yourself, okay, I want to find the area of this. Again, this is the same example we just talked about. You could say, okay, it's made of 2 rectangles. First, this rectangle plus this rectangle. Is that a good idea? No, no. What we do this, it's just going to be, okay, it's going to be a bigger square minus a smaller square. That's going to be the bigger square. I'm going to draw it here. What is the area of this square? This one is 10 squared minus, what is the area of this smaller one? The blue one. Okay, that's going to be minus 10 times 10, 100, minus 9 squared. Okay, so that will give us the answer. 10 squared is 100. 9 squared, 9 times 9 is 81. So far, this is 19. So this gray region, this shaded region is 19. Okay, we had one other part like this again. So we have a 19 so far. Let's just go repeat the same process. Okay, when we want to focus on that, this is what you should visualize, right? I don't recommend doing this in the test, right? This is just for us to visualize better. You say, okay, I'm going to focus on this part. This is basically what I hope happens in your mind when you're dealing with this question. You focus on each one at a time. Okay, so this is, again, a square. This is 7 times 7, right? The red one, 49. Okay, again, this part is seen out. This is 4, right? It's a square, so this is also 4, right? I see some people say 7 times 4. No, right? This is a square, this is a square. So this is also 16. So 49 minus 16. So what is the value of this? Okay, it becomes 33. So this one, now the gray region here is a 33. We also had a 19, so all we have to do is going to be like 33 plus 19, okay? So it's going to be 52. Okay, so we're just going to go with this option, E. Okay, problem 4. When Yunji added all the integers from 1 to 9, she mistakenly left out a number, like it didn't write it. Her incorrect sum turned out to be a square number. What number did Yunji leave out? Okay, so first of all, what are square numbers? Obviously, like first number is 1. What is the next square number? 2 times 2, 4. Next, 3 times 3. Next, 4 times 4. Next, 5 times 5. Next, 36. Next, 49. Next, okay, 64, right? So these are square numbers. You have to think about it like this. This is like, okay, the sum of these numbers is going to be one of these, right? And the next number will be 81, 9 times 9. And then you would go, okay, 1 plus 2 plus 3 plus 4. You would just go and all of them write this. So I'm going to write it all, but you shouldn't do this during the test, right? You want to save time. So 7 plus 8 plus 9. So how do you add all of this? Okay. So basically you could just sum them all up. It's not going to be hard. Okay. Or you could just use this idea here that I have 9 numbers, 9 multiplied by the average of the first one and the last one. So it's going to be 9 times 1. What is the average of the first and the last? 1 plus 9 divided by 2. Okay, so 1 plus 9 is 10 divided by 2, 5. So all of this is 5. All of this is 5. So what is 9 times 5? 45. So that means when we add all of these together, the sum is 45. Now, Yunji mistakenly left out one of them. That means it didn't write one of them. So for example, if I forget to write 1, my sum becomes 45 minus 1. It becomes 44. If I mistakenly don't write 5, my sum becomes 45 minus 5, 40, right? So you just have to ask yourself, okay, we want to create one of these square numbers, okay? So 45 minus which number becomes, can it be 49? No. This is 36. You have to ask yourself, 45 minus which number is actually 36? The answer here is 9. So Yunji didn't write 9. Because now when you add 1 plus 2, 3, all the way to 8, this is actually 36. And 36 is a square number because we can write it as 6 times 6. So the answer to the question is 9. Well, the only reason that somebody cannot do problem 5 is that they don't fully understand the question. Because if they did, there is nothing difficult about it. So Alia rolls 2 standard 6-sided dice. Okay, we roll it and then we see the numbers. She notices that the product of the 2 numbers rolled is a multiple of 6. Okay, let's review. What is multiple of 6? The first multiple of 6 is, of course, 6. The next one is 6 times 2, 12. The next one is 6 times 3, 18. The next one is 6 times 4, 24. And 30. So we'll roll 2 dice and some numbers appear and we multiply them. Okay, so what we get, for example, we could get 1 times 6. Okay, right? So we would get this number. Okay, so we could also get 2 times 3 to get 6. Now, what does the question want? Because the product of these numbers is now a multiple of 6. Which of the following integers cannot be the sum of the 2 numbers? Okay, sum means we just have to add them. Okay, so 1 plus 6 is 7. So 7 can be the sum of the two numbers because we just showed it. Because here the question says cannot be. So I'll have to eliminate 7 because obviously 7 is possible. 2 plus 3 is 5. So, okay, 5 is possible. So 5 can be the sum of them, right? So we just have to find new numbers, okay? How about 12? Which two numbers you multiply and you get 12? Okay, 3 times 4 is 1, right? So then I have to go 3 plus 4 is 7. It's already out. So another way to get 12 is by 6 times 2, right? Is 12. Now 6 plus 2 is 8. So 8 is out. Okay, so the answer is either 6 or 9. So which two numbers we could multiply to get 18? Okay, so 3 times 6 is another one. So 3 plus 6 is actually 9. So 9 can be, okay? So 9 is out. The only number that cannot be is 6. So we just select this. So if you understand the question, I think there is nothing difficult about it. So this question could be more difficult for non-English speakers, like people in China, in like Asia. So maybe sometimes they don't know these words. That would make the question difficult. Okay, Sergey skated around an ice rink, gliding along different paths. The gray lines in the figures below show 4 of the paths labeled PQRS. What is the sorted order of the 4 paths from the shortest to the longest? Okay, so of all of these, which one you think is shortest? To find the shortest, we have to have a comparison between these two, right? So one of them is the shortest. And to compare, let's just start from here, for example. Imagine this is the starting point. So both of them will go up. This goes up. This goes up. So after here, this one will go a little curve. This one goes in a line. This one continues going in a curve. But this one again goes in a line. Which one is less? You see, so for example, from here to here, we basically have to compare these two now. Okay, we just have to do a comparison of these two. The red line is longer or the yellow one here? Okay, because the yellow one is obviously less, we go straight. So that means this one that uses line will be less. Okay, so then because the yellow was shorter than the red one, so this is the shortest. Okay, so because here it says from shortest to longest, they have to start with R. You're not starting with R. You're not starting with R. You're not starting with R. So 3 options are bing, out. And then after R is going to be P, obviously. Okay. Or because now we have to decide, let's go and decide it. Maybe it's not obvious to everyone. So we have to do a comparison between P and S to see which one is actually longer. So let's go here. P and S. Okay. So again, let's just start. So from here, both of them have the same starting points. Okay. This one goes on a curve. This one goes on the same curve. So far, they're the same. From here, let's look. I'm going to change color to make it easier to visualize for everyone. Okay, so this one will go just down, but this one will go diagonally. So which one is longer? Well, the diagonal one is definitely longer, right? This would be the hypotenuse of this triangle. So this is longer. So then S is longer than P. So P is shorter. So P should be the second one. There you go. So this is the right answer. Okay, so after R comes P. So this is also out. Okay, we don't even have to check Q anymore. This is the right answer, and that's it. I think if you spend enough time on this question in the test, you will get the right answer. But let's do the question anyway together. A 3 by 7 rectangle is covered without overlap by shapes of tiles 2 by 2, 1 by 4, and 1 by 1 shown below. What is the minimum possible number of 1 by 1 tile use? Because that says we want to minimize this. We want to use these, okay, as much as possible. So let's go and use some of these. Okay. So I'm going to use these rectangles. Okay. So I'm going to have like all of these here. And I would go, okay, first let's put them here. That's going to be like 2 rectangles. Okay, and then I'm going to put another one here. So I'll be left with a 3 by 3. So I could go on and put another one here. So how many is left? 1, 2, 3, 4, 5. And then you have to ask yourself, is there a better arrangement? Again. But there's also something else. We could think about it like that. So how many empty like squares do we have here? 3 by 7. A total of 3 times 7, 21. So every time I put one of these here. So for example, I go put it here. Now how many free squares I have? 21 because I used 4 minus 4. Okay, so it's going to be what? 17, right? So, and then I minus it by another 4, 13. Minus it by another 4, 9. Minus it by another 4, 5. So 5 will be a possible answer to the question, right? Because remember, I could use either of these shapes and all of them take 4 squares. So every time I get, okay, another 4, minus it by another 4. And then if I continue, put another one here, it would be 5 minus 4, 1. So what does that mean? Okay, my mouth stopped working. So, and then 5 minus 4, for some reason, I have to write it with the mouth. 5 minus, oh my God. So, and let's see if I write it here. And then 5 minus 4, okay, is going to be 1, right? So what does that mean? Because we remove 4, 4, 4 each time, that means this number is not a possible, this number is not possible, this number is not possible, right? So if I can fit 4 of these shapes only, then my answer will be 5. And if I can, for example, if we could put 5 of these inside, so that means I use 5 times 4, it will be 20. So, and I have only 21 here, 21 minus 20. 1 is also a possible value. So then can we really put 5 of these inside? See, we have to think about it like this, that this is, for example, 1, 4. Can I put it here? Of course not. If I put it in different places, maybe I put them here, anywhere you put them, right? So I have to keep one of these 4s here. So it doesn't matter where you put them. You could only have, okay, one of these here. Okay, the other way to think about it is just to maximize the number of squares. Let's go with a lot of squares, 1, 2, 3. But again, we can't have this here and we'll end up with one of these 4s here. So either way, you could say I could have maximum of 4, these larger shapes. So 5 of them will be left, 1, 2, 3, 4, 5. So the answer to the problem is actually E. For this type of questions, a diagram would make things visually easier and it helps us save a lot of time. So we're going to go with the diagram. On Monday, Tay has $2. Every day, he either gains $3 or doubles the amount of money he had. So maybe plus by 3 or maybe multiplied by 2. How many different dollar amounts could Tay have on Thursday, 3 days later? Okay, so we start on Monday and we have $2. Okay, So for the next day, we could either have plus by 3, 5, or we could get 4. Okay, this is for Tuesday. And then the next day for Wednesday, okay, the same thing will happen. We could either get 10 multiplied by 2 or plus it by 3, we get 8. So the same thing, we could either get multiplied by 2, we get 8, or add 3 to the previous number, we get 7. Okay, so as you see, something like this happen here. So these are both 8, so they're going to produce the same values. So at this stage, okay, the answer is over, right? You could just say, okay, 2 more, 2 more, 2 more. So just go on and pick 6. Okay, why? We could actually go and see it clearly here. So 10 plus 3 is 13 or 20. See, 2 more values. Okay, because 8 is different, it's going to produce 2 more unique values. So it's going to be 11, double it, 16. And guess what? This 8 is going to produce the same dollar amounts. And this one will give us 10. And so here, double it, 14. So these are 6 unique values. But this 8 is going to produce again, plus by 3, 11. Double it, 16. And we already have these amounts right over here. Okay, so they're not unique. So how many dollar amounts could they have on Thursday? Okay, at this stage, the answer was clear. 3 unique numbers multiplied by 2, they're going to give you 6 ways. So this could save a lot of time. For problem 9, usually everyone uses equations, but I'm going to show you something that is even usually easier, that most of the time makes us a lot faster. So let's do this. All the marbles in Maria's collection are red, green, and blue. Remember, don't write X, Y, and Z. Just pick the first letters. It helps you save time. Maria has half as many red marbles as green marbles. So which one is more? Red is more or green is more? It says red has half as many red. So reds are half of green. So for red, I'm going to give it 1 box. For green, I'm just going to give it 2 boxes. Okay. And has twice as many as blue marbles as green marbles. Okay, so the blues are going to be twice of the green. Green is 2. Blues are going to be 4 boxes. So a lot of you would already know the answer already. Which of the following could be, right, the total number of marbles in the Maria's collection? So when it says could be, that means there are a lot of different answers, right? So if I put here 1, so if R is 1, green will be 1 and 1, like 2. This will be 4. So we have 7 boxes, 7 times 1. The total would be 7. You could also go 4 plus 2 plus 1, 7. Is 7 in the answers? No. Okay. So if this one is 2, I think you get the idea here. 2, the next one is 4, the next one will be 8. If we add them together, it's 7 times 2. You know where I'm going with this? If I put 3 in them, it's going to be the total number will be 7 times 3. So we really want a number that is multiple of 7. Are you multiple of 7? No, 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 yes. That's it. So you could also go here. If R is 4, green has 2 4s, so green will be 8. This one will be, of course, 4 times 4, 16. See, this is basically the same as equations, but when we visualize this, everything is crystal clear, and most of the time we're even faster. So just this method is really, really powerful. If you have a problem with this type of question, do you know what you're doing wrong? So 99%, you're not reading the question well enough. You're probably reading it too fast, or you're reading it as if you're just reading newspaper. right? So you read it, but you don't analyze the information as you read it. So what will help you? A diagram. If you draw a diagram, then you force your brain to analyze the data before you answer the question. Now let's read it. In January 1980, blah, 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 not important, recorded carbon dioxide levels 338. Again, those are not important. Over the years, the average carbon dioxide reading has increased by about this amount. What is the expected carbon dioxide level in January 2030? Round your answer to the nearest integer. Okay. So we have to see it like this. Things started at this year, right? 1980, everything started. And what was the level of carbon dioxide? At this time, it was 338. And did it increase, decrease? What happened? It increased. At which year? It stopped by, we want it for 2030. So that's okay. You don't have to draw a diagram, but you have to have this visualization in your head, right? So it's going to be like this. Now, each year, it's increasing by only 1.5. So 1 year later, okay, it's going to be 1.5 added to it, plus 1.5. And again, plus 1.5. And again, next year, plus another 1.5. And you do this. So this is the visualization you need to have, right? When you read the question, even when you don't draw it, you have to have this. If you don't have it as you read it, then the question becomes difficult. Okay. So we just have to go from this year to this year is how many years? 50 years. And 50 years of plus 1.5 plus 1.5 plus 1.5. Okay. So now I rounded this number to 1.5 only because you see the answers are, you see, they're too far. So what I could do is just go and multiply by 1.5 for now, right? Let's go 1.5. What is 50 times 1.5? 75. Okay. So now that means through this 50 years, 75 was added to this number, initial number. That's it. So what is 338 plus 75? I'm going to write it here. 338 plus 75. Okay. This will be 3, 11, 4. So 413. Okay. So it's closer to this option B. Okay. So remember also we rounded this down and your answers is 413. So it's supposed to be slightly more. Okay, that's it. So you see, a diagram helps organize our mind, right? To really understand the information. Before we actually try to do the question, let's go review a few points and then we come back and deal with it. Okay, now let's find 3 and 5 on the coordinate plane. So we know that the first number appearing here is x value and the second one is y value. And we know this one is x-axis, this one is y-axis, right? So to find this, we go 1, 2, 3, okay, and then the y value 1, 2, 3, 4, 5. So the point will be around here. Okay, this is point 3 and 5, right? X value is here 3. Y value here on this graph will be 5. This is 3. Okay, so I'm pretty sure you know this already, but the thing I wanted to check with you, if I want to move to the right, 1, 2, 3, 4. So I'm going to go to this new point. Okay, so which one of these would change? The first one would change or the second one would change? When we go to the right, we're changing x. And I went 1, 2, 3, 4. So this number will be plus by 4, okay? So this one will be 7, but the y1, 5 never changes because both of these 5s are around this line, which is 5. So when you go to the right, x becomes more. 3 plus 4 is 7. Now, if I go to a higher point, okay, so for example, if I go here, I'll go 1 here. I just want to go 1 more, okay? So can you tell me how the number would change? This one will change or this one will change? Now, the x value, when we go up, x value would not change, okay? Because we're already here. Okay, the y value will increase by 1. So let me write it here. This point here will be 3, but y value will just go 1 up because we moved almost, my graph is not that precise, 1 up. Okay, so in other words, when you're going to the right, you're changing the x-axis by 4. When you go higher, okay, the x-axis will not change. This number and this number, 3 and 3, this one will increase by 1, okay? So this is what we need to be able to do problem 11. Now let's go and deal with problem. Okay, the coordinates of ABC are these, as you see them, with y greater than 7. The area of this triangle is 12. What is the value of y? So let's just compare A and B first. Which one didn't change? The y value wouldn't change because we're just going this way. So how large is this? Okay, we just have to subtract these two values. Okay, 11 minus 5 is actually 6. So how large is this? Remember, if I now add 6 to this, it becomes this 11. So AB is already 6. So I'm going to go right here. Now the next point is that the area is 12. So if this is the base, right, we need the height, okay? And height should be starting from here, okay? So when I ask my students to draw the height, some of them would go on and say, okay, maybe here, but they know that it's actually wrong because none of these are 90 degrees, okay? So the height for this one, which is perpendicular to this, is this one. So we just have to continue this, okay? They make 90 degrees right over here. Now, what was the formula for triangle? You would multiply this by this purple one. You divide it by 2, then it becomes 12. So I'm going to put here a question mark. So let me go and do this now. So we know that 6 times this question mark, and then we divided it by 2 is 12, right? So what is the question mark? The question mark is actually 4, right? Because 6 times 4 is 24, divided by 2 is 12. So the question mark is actually 4. Right? So it's easy peasy now. What is the value of y? Okay. Now, you see, this is the important part. When we are going, what is this point over here? You see now, the x value of this is already 3, okay? Because it's going to be the same as this. When we go up or down, the x value wouldn't change. The y value would change. And now, what is the y value of this? Okay, the y value of this, look at these points now. It's 7, it's 7. So this must also be 7. Okay. So when you travel to the right, you see now 7, 7, 7. But when you go to the right, it becomes 5. Then this becomes 11. When you go to the right, the y values wouldn't change. 7, 7, 7. The x values are changed. So now let's go. So I'm going to clean all of this. So this point is 3 and 7. This point is 3 and y. Okay, the x, when we go up, the x values wouldn't change. So we have 3 and 3. This is 7. And we go higher by 4. So y would be just 7 plus 4. So the answer to the problem is 11. So I'm going to pick this option right over here. Okay, let's do problem 12. With a little algebra, problem 12 is actually very straightforward. Let's read the question. Rohan keeps a total of 90 guppies in 4 fish tanks. There is one more guppy in the second tank than the first tank. There are 2 more guppies in the third than in the second, and there are 3 more guppies in the fourth tank. Okay, so and so on. With this type of question, okay, you just have to find the tank which has smallest number of units. In this case, guppies. Like, okay, which one is the smallest? Okay, the one that is the smallest, you call that x. So here, the first one has the smallest value. So I'm going to call this one x. Okay. So here it says there is one more guppy in the second than in the first. If the first one is x, then this one is one more. So it will be x plus 1. Good. Let's read the next sentence. There are 2 more guppies in the third tank, okay, than in the second tank. There are 2 more guppies. So tank 2 was x plus 1, right? It's the same. But here it says there are 2 more guppies here in the third one. So this one will get an additional 2. Now you tell me, what is x plus 1 plus 2? Okay. X is a variable, but we could add the numbers. So all of this will actually become x plus 3. So I'm going to go and write here x plus 3. Good. And let's read the last part. There are 3 more guppies in the fourth tank than the third tank. The third tank, I'm going to write it here. This was x plus 3 already. But here it says it's 3 more. So I'm going to add 3 more to it. So x plus 3, we could only add the numbers together. So it's going to be x plus 6. So all of these together, x plus 1 plus x plus 3 plus x plus 6, all of them are 19. So all we have to do is just add them all together. So you see this one has x, another x, another x, another x. X plus x plus x plus x. How many x's? 4x. So I'm going to write here 4x plus. Let's add all the numbers. 1 plus 3 is 4, plus 6 is 10. So I'm going to write here 4x plus 10 is equal to 90. So the next line will be 4x is equal to 80. Divide both sides by 4, and you will get x is equal to 20. Good. So should I go on and choose option A because I have 20? That's probably what a lot of students will do. But the question is saying, how many guppies are in the fourth tank, right? So you just have to add, x is 20, add 6 to it. So the last tank will be 20 plus 6. So it's actually 26. And I'm pretty sure some student will fail at this the last part. So the answer is 20. This is a fun question, but if you're not careful enough, It's very easy to make a mistake when doing this question. Buzz Bunny is hopping up and down a set of stairs one step at a time. In how many ways can Buzz start on the ground, make a sequence of 6 hops, and end up back on the ground? For example, one sequence is, as you see. Okay, so we're going to have 6 hops, okay? And we want to go back to our starting position. So how many ups, how many downs? Because we want to go back, 3 ups, 3 downs. Okay, that makes it easier. And now I have a question for you. If Bunny started like this and wanted to end up again there, like it could go up and down, will this make a difference? If the bunny starts from the ground or if the bunny starts from the middle, will that make a difference? The answer is yes, they're not going to be the same, because here, if the bunny starts like this, bunny is allowed to go down and is allowed to go up. But bunny at the beginning is not allowed to go down. There's no more stair to go down, okay? So I'm going to put like 6 lines like this, and we're going to choose 3, 4, 5, 6. Definitely the first one is up. And I have a question for the last one. Can the last one be up? Can we go up and then get to the like ground level? So do we have a -1? Can we go underground? No. So these 2 hops are already forced. This one is up, this one is down. So we need to decide for 4 hops, not 6, only these 4. We need 2 ups, okay, and we could place it anywhere here. So my 2 ups could be here, or my 2 ups could be at the end, right? So there's a formula for it. I have 4 positions. I want to choose 2. Okay, so it's going to be a combination of 4 and 2. Okay, this will be 6 ways. But we still have to be careful, okay? Because if I go 1 up, can I go still 2 down? No. If I go 2 up, can I come back 3? No. So it's advisable to just make the list, okay? It's not a lot, there's just 6. I'm going to make all the list. So I'm going to have 2 ups, okay? I'm going to put them here first. My ups are going to be like this together. Then 1 up here, 1 up here, 1 up here, 1 up here. Okay, so I'm done with putting ups here. 1 up here, 1 up here, 1 up here. Okay, and 1 up here. So we have 5, and the last thing 2 ups are at the end. So the ones that I didn't draw, they're downs. Okay, so it's going to be like this. I could just make the downs here as well. So down, 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 down. Okay, you didn't have to draw this. I'm just drawing these so that my answer will be clearer. So I have 6 ways. Remember, at first we're already gone up, 1 up. So which one is not possible? We could go 3 up. Okay, it's fine. So here 1 up, 2 up, 1 down, fine. So remember, this one could be problematic because we're going 2 down together. But before that, we went 2 up and then we're going back 2 down, fine. 1 up, 1 down, fine. Okay, 1 up, 1 down. Okay, the only one that is actually not possible is that the last one, okay? Because you're gonna go 1 up here, and then you want to go back 2, impossible. Okay, so this one is the only one of these 6 ways that is impossible. So correct, 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 correct. So the answer to the problem is actually B. I don't think problem 14 is very difficult. It's, I think, very straightforward, even though it's problem 14 and you expect it to be more difficult than the previous questions, but probably not. The one-way routes connecting towns AMC8, are shown in the figure below, not drawn to a scale. This is really important, right? The distances in kilometers along each route are marked. Traveling along these routes, what is the shortest distance from A to Z in kilometers? Okay, so they're not drawn to scale. So usually if you think of this as a triangle, you say, okay, going from one side of the triangle should be shorter, but they're not drawn to scale. So probably, so we could think about it, X, for example, is here. And imagine that, for example, M is here. If this is 5, this is 2, something like an 8 should be longer. Probably this is like 8 now. But it's not drawn to scale, okay? So you shouldn't worry about that part. Now here, all we have to do is, like, for example, if I want to go from A to M, what is the shortest path? Okay, I could go with 1/8, or I could go 5 plus 2. So the shortest path to M is going to take 7 kilometers. Okay. Now, what is the shortest path to Y? To M was 7 plus 6 is 13. Okay. Or I could go 5 here and then 10 here. This is 15. So the shortest path is this, and I'm going to write it here. The shortest path to Y is actually 13. Let me write it down here. Okay, let's do it again here. What is the shortest path to C? Up to here was 7. This is going to be 21. Okay, if we go it this way. But if we go 13 plus 5, it's actually 18. So I'm going to write here 18. See, I'm just going to go and write the shortest path for all of them, right? So from C to Z, okay, if I add 10 to it, it's going to be 28. But if I go 13 plus 17, it's going to be 30. So what is the shortest path? Okay, 18 plus 10. So that's going to be 28. Option A is the right answer. So, but just the question, like, learn the system I used. I just compared each point, for example, M. There are 2 ways. Okay, and I wrote only the shortest one. To go to Y, so there are 2 paths. Maybe this one or maybe this one. Then we just calculate and write the shortest value over here. And then it would be very straightforward. So the way we went was like this: 5 plus 2, 7. Okay, and then another 6, and then another 5, and then another 10. So we add them all up. It's going to be only 28. Problem 15. Let's first read it. Let the letter fly bog represent distant digits. Suppose fly is the greatest number that satisfies this equation. 8 times fly is equal to bug. What is the value of fly plus bug? Okay, so when you see this question, immediately you have to remember 1001, right? That these numbers are being multiplied by something like this, okay? If you don't know, so let's go and review a little, and then we come back and deal with the question. Now, if I go and press 1, 2, 3, and I multiply this by 1001, what do I get? 1, 2, 3, 1, 2, 3. Let's do it with a different number. If I go with 225 multiplied by 1001, I get 225 and 225. And the reason of this is actually simple. It's not like magic. It's just, let me make this larger. So 225, right? I could write this number as 225, okay, with 3 zeros plus 225. Okay, if you're not sure of this, write it vertically and try it before you watch the rest of the video. Okay, and then you see now, this is 225. Okay, and this is 1,000 times of this. So for example, if I call this one X, This is 1000x, right? So now if I go and add them all up, okay, 1000x plus 1x is equal to 1001x, okay? And what was x? X was 225. So all of this is the same as 1001 multiplied by 225, okay? So I'm going to just clean what is in between and let's see what we have. So 225 is equal to 1001 multiplied by 225. Now, if I go and, for example, here, if I write fly, fly, for example, like the example, and if we just repeat the same process, fly, fly becomes what? Instead of writing the 6-digit number, I could just write the 3-digit version of it, which is going to be fly, multiplied by 1001. Okay, so any 3 digits that you pick multiplied by 1001 will be repeated. Let's go and use this in our actual question. Now let's just go and apply what we just reviewed together. So 8 times this one. So instead of this, I'm going to go on and write 1001 times fly. So it's going to be 8 times 1001, okay, multiplied by this fly here is a 3-digit number. So is equal to, this is again following the same pattern. So I could write it as 1001 multiplied by BUG bug. Okay. So as you see, this 1001, okay, is repeating. So I could go on and divide. Now I can divide both sides by any number that I want, right? So 1001 divided by 1001, both cases are going to be 1, okay? And 1 times bog here is going to be bog. So I would just go on and clean this part. And the same here. So what I'm going to have is 8 times fly is bog. So I just simplified this part of the equation. Now look, this is being multiplied, okay, by 8. So that means this is also multiplied by 8. And the question is asking us, what is the greatest number that satisfies this equation? Okay. So to find the greatest number, I would focus on this part. Let's find the greatest 3-digit number that is divisible by 8. We multiply this by 8, so this is divisible by 8. So let's go and find it. We know that 1000 is divisible by 8 because 1000 divided by 8 is 125. So how do you find the next number? We just have to subtract it by 8. It becomes 992. 992 is the greatest number that is divisible by 8. Okay, but is this going to be the same as, because this has to be bog? See, now it's going to be like this. First 9 becomes B, and then 9 becomes U. No, because here it says they represent distinct digits. B cannot be 9 and U again 9. No. So what should we do? We should continue the same process. Let's find the next one, the next great number that is a multiple of 8. So I'm going to go minus this by 8. So I'm going to get 984. Now 984, okay. So let's see it here. We could compare them like here, this time. So B becomes 9, U becomes 8, G becomes 4, right? It's very good. So this is the number. So we have the value of this, 984. So let me write it here. So we just need to find a 3-digit number that when we multiply it by 8, it becomes 984. So it's easy. All we have to do is divide 984, okay, by 8. So you could do it here. The answer is 1, 2, 3. So that's going to be the value of fly. So fly is 1, 2, 3. So all we need to do is just add these two numbers together. And even if you want to be smarter, so you see now, if I just add this digit by this digit, 3 plus 4 is 7. And the only option that has 7 in it is C. So if you are certain about our numbers, we just go on and select this one. Or just to be safe, you could just do the whole addition and check. Well, in my opinion, problem 16 is the second most difficult question of the whole set. Problem 25 is the most difficult. And after this problem, I believe, is the most difficult. Now, let's read the question together, and I'm going to talk about the strategy we need to use for a question like this. Min enters the numbers 1 through 81 into the cells of a 9 by 9 grid, okay, which is going to be the full grid. All of it is going to be filled. She calculates the product of the numbers in each row and column. What is the least number of rows and columns that could have a product divisible by 3? What does that even mean, right? I don't know, right? When I first read the questions, it's what a weird question. And I think everybody else is feeling the same, right? You read a question like this, the answer is, I don't know, right? Because it's even hard to understand the question. So what do we do? Are you going to risk it and draw a 9 by 9 grid during the test? No, we never do that, okay? We start by the easiest numbers. We come up with an easy example. We find what's going on, and then we come back and deal with it. Maybe we don't even have to draw the grid. Actually, when I did this question, I didn't draw the 9 by 9 grid. I didn't do it, but still I managed to answer it. Let's see how. First, the easiest grid we could draw is a 2 by 2 grid, right? And then we put the numbers in them randomly. 1, 3, 2, 4. Now, what is the product of this row? Like this row, the product will be 2. This one will be 12. This column 1 times 3. This one is 8. Which ones of these rows and columns are multiple of 3? See, this row 3 times 4 is 12. 1. This is 1 times 3. Okay. The columns and the rows that share this 3, both of them became multiple of 3, right? So we do it, then I say, I'm starting to understand something. And then you draw the next one. I'm going to go draw a 3 by 3. You do this until you understand the task. Most of the time, unless you do this, what I'm doing now with simpler examples, you don't even understand the task. So how are you supposed to answer a question you don't understand? Okay, so now let's just go here. I'm going to put the numbers again randomly. 1, 3, 6, 9, 2, 4, 5, 7, and 8. Now, which rows and columns? Tell me, this is going to be 1 times 7 times 8, 56. Is it a multiple of 3? No. Why isn't it multiple of 3? Because I don't see a number. I don't see a 3. I don't see a 6. I don't see a 9. Why would it be a multiple of 3? How about this one? Is it the multiple of 3? The answer is yes. I don't even have to go, no, what is 9 times 5 times 3? I don't even have to do it. Because I see a 3, automatically it is this row, the product of it, is already a multiple of 3. So the same story like this. This one is because I see a 6. So Okay, so what I'm going to go like this. The first row doesn't have a 369. No, this one, yes. This one, yes. Now let's focus on this. You tell me, is the product of this a multiple of 3? You don't even have to multiply it. Do you see a 3, a 6, or a 9? No. So this column is not. 7, 3. I see a 3 here. So this column, yes. 8, 9, and 6. I see a 6. Yes. Now, the question is, what is the least number of rows and columns that could have a product divisible by 3? Okay, we want to minimize this. Okay, so that means really all the numbers are not really important. The only important numbers are 3, 6, and 9. If I put 3 here, both of these, this row and this column, will be, okay, automatically divisible by 3. So now, if I put 6 here, what happens? If I put 6 here, then one more row and one more column will also be divisible by 3. So it will be 4. But if I put 6 here, okay, this one is already divisible by 3. So, and this one. So it will become, right, only 3, not 4. Okay, I don't think this part was clear. So if I put 3 here, good. If I put 6 here, 2 more. Let me clean it here. If I put 6 here, 1 more, 1 more. If I put 9 here, all of them. So if I put 3, 6, 9 in this way, all rows and all columns will be divisible by 3. That's the maximum. The question is asking for the least. So if I want the least, I need to put these numbers compact. I want to put them together. Now, if I put the numbers, this column, yes. This column, yes, 2. This row, yes. This row, yes. So the minimum will be 4. For which question? For a 3 by 3 grid, is 4. For a 2 by 2 grid, 2. For this one, 4. So now, maybe you draw another one, 4 by 4 grid, or I think we could already answer the big one, right? Let's just use our experience, okay, to deal with a 9 by 9 grid. Okay, let me go and draw one. Okay, now let's go and use our experience with simpler examples, okay, and apply it to a 9 by 9 grid. Remember, in the test, you don't have to draw this fully, right? Just something simpler will just so do the job. Okay, now, when in a 2 by 2 grid, we only had one number that was multiple of 3. In a 3 by 3, we had 3, 6, and 9. In 9 by 9 grid, how many numbers will be multiple of 3? So I'm going to make a list. I'm going to clear this. The first number is 3. The next one, 6, 9, 12, all the way to 89. So how many numbers are here? 3, 6, 9. All we have to do is divide them by 3. So we have 27 numbers. Okay, good. So because here it says the least number, okay, we want to put them compact as possible. How is that possible? Okay, the way we do this is gonna be, we just gotta go and select a 5 by 5 and put 25 of these numbers here. So for example, I'm going to write some of them as example. 3 here, 6 here, 9 here, maybe 12 here, 15 here. We just put all these numbers here, okay? It's going to be filled. How many numbers will be left? We had 27 of them. And we need to take 2 more of this. Okay, remember we want to put them as compact as possible. If I put this number here, okay, I will put it again. I could put it here, but I want it to be closer, right? More congested. So I have to put it here. Okay, now let's count all the rows and columns that will be multiple of 3. Okay, this one, of course, 1, 2, 3, 4, 5. Okay, so there will be 5 more like this, right? It's going to be 1, 2, 3, 4, and 5, obviously. So we have a 5 plus 5. And this one, because I put it here, they will just get one more row here, plus 1. So it's going to be 11. That's the right answer. Okay. Remember, if I go and put these 2 red ones, yellow ones, sorry. If I were to put these yellow ones here, right? So again, 5 by 5, that's 5 like this, 5 columns like this, 5 rows like this. Then it would become 1 more, and again 1 more. It would be 12. But we want the least. Because we want the least, so if we put them like this, that would be the least. 5 horizontal, 5 vertical, plus this 1, it would be 11. Okay, so that's the right answer to the problem. So all the things, just a recap. When you see a question like this, you have to start by easy examples, and you do it first, as many as needed, right? Until you understand the task fully, right? Maybe you establish the pattern, or maybe you just use that experience and attack the main question. That's what we do. Problem 17 is a typical AMC questions. If you did do enough practice, so you must have done some questions similar to this in the past. So anyways, let's just go and deal with this question. A chess king is said to attack all the squares one step away from it, horizontally, vertically, or diagonally. For instance, a king on the center, a square of 3 by 3 grid, attacks all 8 other squares as shown below. Okay, this is like the actual chess game. If you have a king, the king is allowed to move all direction and also attack all direction around it. Okay, suppose a white king and a black king are placed on different squares of a 3 by 3 grid so that they do not attack each other. In how many ways can this be done? So I have a question for you. Can we place any of the kings in the middle? So for example, if I have a black king here, can I place a white king without them attacking? No, both of them can attack one another. So that means none of the kings should be placed in the middle. That's what we know, first thing. The black king, I'm going to go with B, okay? And white king, I'm going to go with W. If I place 1B on my corner, so white king cannot be here, cannot be here, cannot be here, okay? So the white king will be here, 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 right? So for one, if B is on the corner, this corner, there's just like 5 positions. So for the white king, if I put B on another corner, okay, again, 5 more, see? But if I happen to place one of the B's here in the middle of one row or a column, then things would change. Now, if B is here, W cannot be around it, so W will have 3 positions. See, in one case, there were 5 positions available for W. In this case, 3. If you attempt and try to answer the question all at once, then you mix up and you confuse yourself. So this is basically 2 questions in one question. Okay, we call that casework. So first case or first question, you have to go, okay, B is only on the corner. if B is here, as we did here, 5 positions for W, B is here, another 5, B is here, another 5, and another 5. So it's for B, we have 4 positions on the corner. For any positions B is here, we're going to have 5 W's. So 4 times 5 is 20. This is case 1, okay? And case 2 is what? See, in all the cases, B was in the corner. If I put B, so I'm going to have new, okay, solutions, new arrangements, okay? So if B is here, I'm going to have 3, okay? Again, I have 4 available positions for B, okay, for each one. So I have 4 positions for B. If I, for example, put B here, again, I'm going to have for each B 3 W's here. So again, this is 3. So I'm going to go 4 times 3. This will be 12. So now I have to add all these cases together. So it's going to be 12. 12 plus 20, it will be 32. Problem 18 is a typical AMC questions. This idea has been repeated in a lot of tests, AMC8, even different tests. Basically, it says these circles are concentric. That means all of them are starting from the zone, clear in the picture. This radius from here to here is 1. This one is again 1. This one is again 1. And the shaded portion is equal to unshaded portion. And is asking for this angle over here. How many degrees is that? It's going to be one of these numbers over here. Okay, so before I actually try to do this one, let's go, how do we find the area of a donut shape or a bagel shape? Let's go and just check that, and then we come back and deal with this question. Okay, now how do we find the area of this donut bagel shape? We don't have a specific formula for this, but all we need to know, and all you need to know, is the formula for area of a circle. And what we do here is just pi times radius times radius. So you multiply it by radius, you multiply it by radius again. So we write it as pi times r squared, okay? That's how do we do area of a circle. Now, how many circles do you see in this picture? Okay, we see 2, right? So, but what is the area of this donut shape? It's gonna be the big one minus the small one. So for example, I have to assign some numbers here. Imagine the radius of the big circle, the black one, the bigger one is 3. Then what would be the area of this black one, all of this? Would be pi times 3 times 3, okay? People usually write it like this, pi times 3 squared. But it's actually 3 times 3, 9 times pi. So it's actually 9 pi. If you're beginning, like at first, writing numbers like this is so weird, because it's just like, why can't I write it just 3.14 and then multiply them? You can, but you waste your time, okay? Because later, pi is not even important. We're going to simplify it. If you multiply it by 3.14 at this part, you're fine. It's fine. You're just wasting time. That's why we don't do it. Okay, so I'm just going to go write it as 9 pi. Now, we also have to find the area of the smaller circle, right? Imagine this is only the radius here is 1 unit. And we want to find this area over here. For that's 1, it's going to be pi times 1 times 1. 1 times 1, 1. And 1 times pi, pi. So I'm going to write it here. So pi times 1, of course, is pi. Good. Now, what is the area of this donut? It's going to be this big circle minus the small one. It's going to be 9 pi minus 1 pi. It's actually going to be 8 pi, right? So I'm going to write it like this. We're going to go 9 pi minus 1 pi It's going to be only 8 pi. Now, if we want the answer in decimal value, you could go, okay, it's going to be almost 8 times 3. So the area of this part is really about 24, 25, but we don't need this, okay? We just keep this as 8 pi. So now this is the basics. You just had to know this. And with this information, you are able to answer the question. Let's go in, deal with. Now, the question is saying, suppose the shaded and unshaded regions are equal in area. Okay, so now let's go for the regions. The smallest one over here, okay, the radius of this is 1, okay, and it's completely unshaded. Okay, so we just did it previously. It's going to be 1 times pi. So first, the unshaded part is pi. Now let's go for the next one. It's going to be this one, the bigger one. What is the radius of this? The radius of this is 2. Okay, so it's going to be this big one. What is the area of this? 2 times pi. This is going to be 4 pi. But we also need to subtract what is inside. Minus 1 times pi. It's going to be 3 pi. Okay, so this 3 pi is going to be this region here. This one is 3 pi. Okay, let me also write it here. Now, which one is more? Shaded and unshaded. Shaded is already more. It's 3 pi. This is pi. Now we also need to go and find the third layer over here. What is the radius of this? 3. What is the area of this? 3 times 3, 9 times pi, 9 pi. Minus, okay, the smaller one, right? Minus this one now. This was 4 pi, remember? 2 times pi. So what does that mean? That means all of this last layer is 4 pi, okay? All of this is 5 pi. So we're going to imagine we're going to cut this 5 pi and give them to these two groups. When we do that, they need to be the same, right? They need to be equal. So let's go. I have this 5 pi over here. Let's give it, for example, from here, let's give 3 pi to this. If I give 3 pi to this from this 5 pi, 2 pi will be left. I give 2 pi to this. Are they going to be equal? This one is was pi. I added 3 pi. It's going to be 4 pi. But this one is 3 pi plus 2 pi, 5 pi. So I couldn't make them equal. So I need to divide this and cut it differently. So how should I do this? What if I go, for example, give this person 4 pi, and it will be only 1 pi left to give to this one. So 4 pi plus 5, this one will be 5 pi. But now the problem is this one is 4 pi. So how do you do this? How should we do this now? Okay, the thing is, okay, I will have to give this one 3.5 pi. What is 5 pi minus 3.5 pi? Is 1.5 pi. So I give it to this. Now, okay, this is going to be it. So now this one, 3 plus 1.5 is 4.5 pi. This one is again 4.5 pi. So I made them equal. So what does that mean? That means I need to cut this 5 pi that I have in these ratios. Okay, let's look at here. So this one, all of this was 5 pi. And this portion of it is 1.5 pi. Right? This is only 1.5 pi. Okay, all of this, I'm going to just go with red, okay? Pay attention to the colors. All of this is 5 pi, right? Remember, all of this, the red one, I think my microphone got muted. I don't know if I recorded everything properly. So I would just have to say it again. Uh, all of this, all the big, this part is 5 pi, the red one, and the blue part is 1.5 of it. So I could write it like this. 1.5 pi over so the ratio is going to be 1.5 pi over 5 pi, just like this. Okay, now we need to simplify this. Pi is canceled with this pi. So this one will be 1.5 over 5. So we need to get rid of now we need to get rid of the decimal value, 1.5 over 5. To get rid of the decimal, I multiply both of them by 2. So what I'm going to get, 1.5 times 2 is 3. 5.5 times 2 is 10. So the ratio here is 3 over 10. The ratio of this blue part over all the red part is 3 over 10. Now we know that a full circle is 360 degrees. So what is this portion over here? Okay, so it's going to be 360 multiplied by 3 divided by 10. I'm going to divide it first. This will be 36. And 36 times 3 is going to be 108 degrees. So this portion here, which belongs to this angle, is only 108 degrees. So this is 108 degrees. Because 108 degrees is 3/10 of a full circle. Okay, problems 19 and 21 are very, very similar. Okay, so after watching this one, you could just go and give question 21 a try with the same approach. It would be a good practice. So Jordan owns 15 pairs of sneakers. 3/5 of the pairs are red and the rest are white. So from here, because we have the total number of sneakers, so first we're going to have 3/5 of the pairs. We have 15. So first, what is 3/5 of 15? You could go like this, 1 divided by this, 15 divided by 5 is 3. 3 times 3 are 9. Okay, this is one way. Or you could think about it like this. See, you could also, if it's difficult for you yet, so still you could imagine a triangle like the rectangle like this. We're going to divide it into 5 parts. Okay, 3/5 is going to be 3 of this. 1, 2, 3. All of it is 15, right? So 15 divided by how many parts? 5. Each one will be 3. So this one will be a 3. This one will be a 3. This one will be a 3. 3 plus 3 plus 3 is 9. Okay, so both of them are the same ways. You could actually find a value. So 3/5 of the pairs is actually just 9. and they are actually red. So we have 9 red sneakers, and the rest are white. So how many whites do we have? 9 are red, 6 are white. Good. Now here, let's just 2/3 of the pairs are high top. So again, another common mistake is 2/3 of what, right? I had one student who thought 2/3 of 9, and then he got it wrong. So 2/3 of the pairs, again, it means these pairs. So again, 2/3 of 15. So 2/3 of 15, okay, is actually 10. You could also draw a diagram like I did. So 10 of them are high top. So 10 of them are of this kind over here, 10. We have a total of 15, and the rest are low top. Okay, so the red high top sneakers make up a fraction of the collection. Again, the red high top sneakers make up of a fraction of the collection. Again, you have to just go and think about it. When it says the collection, does it mean from the 9 red, or does it mean all these 15? Okay, this is more of an English question, okay? So you have to really understand the meaning of the question. So here it means 15. So that means from all these 15s, how many of them are high top sneakers? Let's go. And what does it want? What is the least possible value of this fraction? Okay. So you have to still, you could be unclear of why do we have at least. Okay. So high top are this. And what would be the least possible value of red high top? Let's check. Let's start with red. So for example, we're just going to go with if, right? If one of them is red of these 10, then none of them will have to be white. But the question is saying that there are only 6 white. So we don't have 9 white. So we can't have 1 red. So red cannot be 1. So can red be 2? If reds are 2, let's just go here. If reds are 2, then whites are supposed to be 8. The same reasoning. We don't have that. Can red be 3? No. Can red be 4? Yes. Because then we have 4 of our reds here, and we're going to have 6 white here. Then we're going to have all of our 10. 6 white and 4 red. Okay? So now let's just also check if I have 4 red here, and all of these are also red, then I'm going to have my 9 red, easy peasy, and all 6 whites will have to belong to this group. So I'm going to ask you, how many, let's just see, high top red high top sneakers. Okay, high tops are this. 4 of them are red. So we have 4 red high top sneakers. The collection is 15. So the answer to this will be 4 over 15. Did you really need any formulas, anything? It's just like completely 100% problem solving skills, right? So how you can approach this question? Nothing else. Okay, let's do the question 20. Any 3 vertices of this cube shown in the figure below can be connected to form a triangle. For example, vertices PQR can be connected to form isosceles triangle. So let's just go draw it here. I'm going to change it P to Q to R. Why didn't it say equilateral? That means they're not all 3 sides are equal. Only 2 are equal. So this one is equal to this one, But this one, PR, is actually larger because it's going diagonally. So what is the question? One, how many of these triangles are equilateral? All three should be equal, and they contain P as vertex. Okay, so we just want the ones that actually, okay, go from P. At this stage, it's advisable to just go and just check the options. There really aren't that many, and 0 is even a possible option. Good. So the worst thing you could do at this stage is just try to just draw any triangles that are possible. Just you're thinking without organization, and that's not good. So first you need to ask yourself, how many different sides of different legs can I draw? Like any of these pairs are possible, right? So for example, I could go from S to Q, I could go S to P, I could go S to R, I could go S to U, I could go S to V. So we have to compare these lengths together. So the smallest one, if you agree, are these, okay, a side of the cube. Something larger would be this, to go diagonal. But there is also another one that is even larger than the red one. So imagine this is your room. You're going from the ceiling of a room to the opposite floor of your room that you're in now. This is definitely the largest one. Because it's set equilateral, we have to just use all three should be blue, right, of the same length, or they should be like red kind, or should be orange kind. So the smallest is like this. These are sides of the cube. So if I go, for example, 2, but if I want to connect them, then I have to go diagonally, and it would be a red kind. So it's not going to work. So I can't use the sides, all three sides. Okay, so I have to go with another one. And again, let's go with the kind of blue. If I go from here to here, how can I continue this? I could either go like this, which would be a side, small. Even if I go diagonally like this, it's still small. This is the red kind. I'm still on one square. Okay, so right now, so far, I have no options. The only one that is left starting from P would be, for example, I go to this R, and then I go to this V, and from V I go back to P. All of these are the same sides, okay? So I have one, that means this option is out. Can I draw more? I'll change my color. What if I go, let's see here, from P I could go to T, and from T, I could go to R again. Okay. And I could go back here. So that's 2. So this one is out as well. So here I had one of my students I checked the questions with. He stopped at this point and said he couldn't find another one. Okay. So he chose 2, which is wrong. But it was kind of obvious that 2 is not the right choice. You see, a cube is symmetrical. Okay. And triangles passing P should also be symmetrical. What do I mean by that? So here, from PR is 2, right? Red and blue are going here. But PV is only 1. And RT is only 1, right? Definitely draw more, because once we're done with the question, because the shape is symmetrical, everything has to be equal. So there has to be at least one more. So let's go and check. So I could go again, P from here, PV. I could go from to here, VT. And then I could also connect this. This will be again another one. So now if you check, so the lines that are going through P, the lines containing P, you see I have blue and green. I have green and red. I have red and blue. See, now we say, okay, everything makes sense. Like 2, 2, 2. This could be a possible value. And if you look for it, there are actually no more triangles to be drawn. So 6 will also not be the option. So we're going to go and choose D. Problem 21 could be extremely difficult or extremely easy depending on your approach. And once I'm done with the question, you're going to be like, oh my God, I didn't do this question. It was really easy. And I believe it is really easy. A group of frogs called an army is living in a tree. A frog turns green when in the shade and turns yellow when in the sun. Initially, the ratio of green to yellow frogs was 3 to 1. Then 3 green frogs moved to the sunny side and 5 yellow frogs moved to the shady side. Now the ratio is 4 to 1. What is the difference between the number of green frogs and your yellow frogs now? Okay, so why do students struggle with this type of questions generally? Because they have learned, okay, when they see a question, they have to go write equations from the beginning. They think in terms of equations, and that's why the question becomes really difficult for them, okay? But what is the easy part? Okay, let me just show you now. So here it says the ratio of green to yellow is 3 to 1. So the smallest possible values are green being 3 and yellow being 1. So let's check if these values are possible. So here it says 3 green frogs move to the sunny side. Okay, so they're going to be minus by 3. This one is going to be plus by 3. And then what happens? Then here it says, and 5 yellow frogs move to the shady side. So yellow will be subtracted by 5. This will be positive by 5. But is this possible? Is it possible? So can we have -1 yellow frogs? No. Okay. So basically it means like this. So there is like 2 groups. Okay, some from green come to yellow, some yellow goes to green. And we need 5 yellow to be moving from here. Okay. So that means the starting value here should be 5. So we at least need 5 so that the 5 can move. If we don't have 5 yellows, how could they move to the other side? So very simple. So that means I'm going to change the starting numbers. Okay, this time, if yellows are 5 and greens are 3 times more, so greens become 15. And we're just going to repeat the same process. Okay, and every time you do the process, you get better at it and you become faster. So greens are going to be minus by 3. This one will be plus by 3. And then the opposite way. So here, they're going to be minus by 5. They're going to be plus by 5. Okay, so what are the 2 values? Okay, it's going to be, this one will be 17. This one will be 3. So the ratio is 17 to 3. Is it 4? No. So this is not good. So we just have to repeat the same process. Now, what if G is actually, if yellow is 6, then G will be 3 times more. This will be 18. And you see now, because we're so much faster, this is the same as plus by 2. This is the same as minus by 2. So let's go and do that. So we're going to go this one plus by 2, this one minus by 2. It's going to be 20 over 4. What is the ratio? The ratio will be 5. We want 4. This is 5. But here, if I go and subtract these 2 values, because the question said, what is the difference between the number of green frogs and yellow frogs now? So green frogs now are 20. Yellow frogs now are 4. So 20 minus 4 is 16. Okay, this was not the answer. So 16 is also a good process. So let's repeat the same process. This one didn't work. What is the next one? Yellow could be 7. G could be 21. This one plus by 2, 23. This one minus by 2, 23 over 5. No, this is not going to work. Okay, so let's go with the next one. This is 8. This is 24. Good. So here, 824, this one plus by 2, 26 over 6. Is that the answer? No. So let's just go on. There's just a little more. So this one is 27. This one is 9. Okay. So this one plus by 2. This one minus by 2, 25. Sorry. This one plus by 2, 29. This one minus by 2. Again, not going to work. So all we have to do is just do this one more time. So if we have 10 yellows, greens are 3 times more, 30. So this one will be plus by 2, 32. This one will be minus by 2, 8. So the ratio is 4. Right now, the green ones are 32. The yellow ones are 8. So greens minus yellow will actually be 24. Okay. So I choose this method because this is the easiest, right? Even if you want to write equations, you have to first get comfortable with it so that you realize the question is just like this one minus by 2, this one is plus by 2. So there were ways to even do this faster because they already gave you options, but I just wanted to go with this. So this is so easy. Question 21, everyone can do these questions like this. I think this problem let down a lot of students during the test, and I know exactly why this happened. Let's read the question and then I'll tell you. A roll of tape is 4 inches in diameter and is wrapped around a ring that is 2 inches in diameter. A cross-section of the tape is shown in the figure below. The tape is this amount inches thick. If the tape is completely unrolled, approximately how long would it be? Round your answer to the nearest 100 inches. Okay, so probably this is how everybody thinks, like as they get the question, right? We have 2 formulas for a circle. The area is pi r squared, and the next one is 2 pi r. And there we go, okay, this is for circumference of it. How long is this one? And this is for the area. And because it says like how long, then they're going to focus more on this formula. And then they start working on the question. But they see as we are starting to unroll this, okay, the thickness of the tape will shorten, get smaller. So after we keep unrolling, the radius and the diameter of the tape starts shrinking. So we have a question with the radius changing. Wow, difficult. But that's how they get confused and probably they guess the question or they leave it. So, but actually, it's, even though it says how long, this is actually an area question. But how do we know this? You have to visualize this during the test. You have to go, okay, I'm going to cut this much of the tape, okay? And we know that this is going to be this amount, like this is going to be like the thickness of it, okay? And then we're going to cut this part of the tape and then like stretch it. And you have to visualize this. What will it look like after stretching it? It would be something like this. Okay, the purples are turning into purple and the red ones are turning into red. So look what happened here. This amount is equal to a rectangle. Okay, what is and the red ones are matching. So the red one in both cases would be 0, 0, 1, 5 and 0 0.015. And then you have to visualize this. What if I unroll all of it and then make it really, really long? So all this tape turns into a very, very, very long rectangle. See, we turn all this tape into a big rectangle. Okay? So, and we know, well, this is the tape. All of this tape is here. So the area of this part, all of this area, okay, all of this area should match this area of a rectangle, okay? But we also know it's made of a lot of layers, right? This one is made of a lot of layers. We stretch it, they're going to be equal. So that's what you need to be able to figure out from the question. The rest is easy. So we know that this area should match this area. So let's first go and find this. So what is the area of this shape? Like the bagel shape? All we really need to do is, so what is from here? This is 1 inch. From here to here is actually 2 inches. So the area of the big circle will be pi 2 squared. The big one is actually 4 pi. Okay, it's going to be this one, the big one. So minus the area that is actually inside, the ring that is inside. This is only 1 inch. Okay, so the blue one is actually pi times 1 squared, which is going to be 1 pi. So now I'll ask you, what is this area here? I'm going to change the color. What is this area here? The green part is going to be this one minus this one. So it's going to be 4 pi minus pi is going to be 3 pi. So the area here is 3 pi. And what is the area of the rectangle? Again, 3 pi. So now let's go and deal with it. So we know that the thickness here is 0.015 multiplied by this big length, right? So all of this, I'm going to call this L, and we're going to go like this. L multiplied by 0.015 is going to be equal to 3 pi. Okay. Now, to make the question easier, instead of 1 point, so we could just make this one. Instead of pi, I'm going to go just 3 because this is an approximate question. So this will be 9. So all we really have to do to find L is going to be divide 9, or we divide 10. Okay, I could also make this 10 because here, instead of pi is almost 3 and something. 3 times 3 and something, you could also put it as 10. So either way is fine. You could go with 9 or you could go with 10. So L would be 10 divided by this value. So I'm going to go like this. Let me give myself some space here. So L would be 10 divided by this value, 0.015. Okay, so, or I could also write this as a fraction. I would write it as a fraction, 0.015. Now, how do we get rid of this decimal? See, you have to think about it like this. If I multiply this one by 1,000 and multiply this one by 1,000, what do I get? The numerator will become 10,000. The top number will be 10,000. And look, I have 3 zeros and 3 decimal places. So this number will be 15. So what is 10,000 divided by 15 approximately? It's going to be, the closest value to it will be 600. So the answer to the problem is 600. So this one, I would say it's mostly about problem solving and how you could really understand what's going on. The rest, finding the area and doing this division, is not really that difficult. Problem 23 could potentially take a lot of time, especially in the test. It's 23. If you're a little stressed, that's what will happen. But still, we could do things to be able to do this question rather quickly. Let's see how. Rodrigo has a very large piece of graph paper. First, he draws a line segment connecting these points and colors the 4 cells whose interiors intersect the segment as shown below. Okay, so interiors will be like the colors inside, and you would see that this line and these colors, of course, intersect. Okay. Next, Rodrigo draws a line segment connecting these huge points. Again, he colors the cells whose interiors intersect the segments. How many cells will he color this time? Okay. So obviously, we're not supposed to draw all of this. So, and you could see that 3 zeros, 3 zeros, 3 zeros, 3 zeros. So it's telling you that, well, these numbers, they have to be simplified and we have to work with easier numbers. But let's just check how. So for example, I have 0 and 4 here, 2 and 0 here. If I divide them here, okay, both of these values by 2, so I'm going to get 0 and 2. So this point, if I divide it by 2, becomes this point. Now let's go by this one. Change color. This one over here. So again, I have 2 and 0. If I again divide it by the same number, so I'm going to get 1 on x and 0 here. This one will be, okay, so this point becomes this, right? Let's just try. So when we divide everything by 2, we're going to get this shape instead. And again, how many intersections? This one and this one. In other words, when we divide everything by 2, instead of having two of these rectangles, we're going to get half of it, okay? So what does that mean? That means we could do one of them. It's intersecting 2. And then we multiply it back by 2. Okay, so we just checked that simplifying this would actually work. So instead of working with these big numbers, all we have to do is work with 2, 3, the first point, 5, and 8 on the next. We're going to find the answer, and then we're going to multiply it by 1,000. Okay? So now, just like take a look at the options. We could already cross some of them. See, is it possible to, for example, go through 6.5 square? Do we have such a thing? No, it's just like we have 1, 2, 3, always integers. So when we multiply them by 1,000, okay, maybe we get 6,000, 7,000, 8,000. But this means that this line is going to cross 6.5 squares? No. So this one is already out. This one is already out. Okay. So we're just going to go these 2 points. See, if you just want to find these points, okay, remember, this is the x1, this is the y1. X will be 2. This one will be, okay, let me just go here. We're just going to draw this one, x2, y3. And for this one, x5 and y8 would be here, somewhere here. And we don't have enough graph. So see, this is a trick that we use. We just save extra time. So now take a look. We want to go from x2 to x5. So that means we're going to go 3 horizontally. Like we're going to go 3 this way. Okay. And then from this y3, we're going to go y8. So we need to go how many up on y-axis? When you go from 3 to 8, you go 5 up. So we're going to go 3 right, 5 up. And does it matter if I start from here, for example, go 3 up and 5 up? No. So let's just start it from somewhere lower, maybe here, so that we just use the grid that we already have. I'm going to go 3 up, 1, 2, 3, and 5, 3 right and 5 up. 1, 2, 3, 4, 5. So all I really need to do is connect these 2 points. This way, I don't have to draw a grid, which would take time. Okay, now we just have to see, okay, this line segment passes how many of these interiors? This one, 1, obviously. This one, 2. Okay, this one is a little tricky, but it definitely passes this one, 3, 4, 5, 6, and 7. So it's going to pass 7 squares. We multiply it by 7. It's going to be 7,000. So C is the right answer. But see, some people will just have doubt, right? So for example, when I had this line over here, is it really passing this one, or I'm not drawing it well, right? So is there a way to really check this? Okay, that is passing this. The answer is yes. Okay. So remember, we wanted to go 5 up, 3 forward, right? We wanted to go 5 up, and we wanted to go 3 forward. That's what we did. See here, it's a ratio question. When we want to go 2 up, so how much forward should I go? Okay, with the same ratios. If this one wants to become 2, okay, I have to divide it by 2.5. Then this becomes 2. Okay, let's go here. 3, if I divide this by 2.5, what is 3 divided by 2.5? Is it 1 or a little more? It's a little more, so that's why here it's saying that this one is a little more than 1. Remember, 1 is here on x-axis. We're a little to the right, so this is not a coincidence. This is not a bad drawing. It's actually like this. So when we are at 2 here, which is going to be this one, the x value is 3 divided by 2.5. So we're a little forward. So we're actually right. This one, we need to count this. So this would be the way to check it. If you're saying, oh, maybe I made a mistake, I didn't draw it well, you could check it like this, but you don't have to. So we already have the answer. It's 7,000. Okay, let's review the question together. Okay, this one is 8 feet high. This one is 12. Okay, they're going to be 2 90-degree angles here, 145, 145. Okay, so the only extra point here that is not in the picture is the total area. All of this area is actually 183, okay, units or square feet. Okay, and what does the question want? It wants this one from here all the way to here. Okay, this is what is needed to find. Before we start doing the question, let's go and review some of the concepts that we need to be able to do this question, and then we come back and deal with it. Okay, this is a right triangle. And how do we find the area of a right triangle? We multiply the base by height, and we divide it by 2. Okay, we get the area. Okay, and there's also the Pythagorean formula, which is a squared plus b squared is equal to, okay, the largest side, c. Okay, it's going to be c squared. Okay, I'm pretty sure most of you know this. Now, in the question, it says both of these angles are supposed to be 45 degrees. Right now, to me, this is like 30 degrees almost, more or less. This is like 60 degrees. Okay, so if I turn this into 45 degrees, how does my right triangle change? It's going to be something like this. Okay, now since both of these angles are equal, then our triangle becomes symmetrical. Okay, and that means this side will be equal to this side, and we're going to have an isosceles right triangle. Okay, so in this case, so let's just practice a little. For example, if this one is 5 and this one is 5, so how large would be the largest, the hypotenuse? Okay, we're just going to follow the same formula. This one will be our c. I'm going to have c squared is equal to 5 squared plus 5 squared. Okay, so c squared will be 25 plus 25. It will be 50. Okay, and c will be a square root of 50. Okay, remember, a square root of 50, I could also write it as a square root of 25 multiplied by a square root of 2. So what is a square root of 25? A number that is multiplied by itself and it becomes 25 is 5. 5 times 5 is 25. So this is actually 5. So I could write it here. C will be 5 square root of 2. Okay, and this is always true. So what do I mean by that? So for example, if I change these values into a different number, so for example, if this one is 8, this one is 8, this one is 8 square root of 2. Okay, so this one is 1,000. This one is also 1,000 because remember, the angles are 45 degrees. So this one will be 1,000 square root of 2. Okay, this is all you need, okay, to be able to answer this question. And now let's go and deal with it. Now, where should we start? We have all this information, all these numbers. So I would say the best place to start is focusing on this 183. So we have the total area, okay? And they're asking for h. So you could also think backward. If I had h, would I be able to find the total area? Okay. So is there a formula for finding area of mountains? Of course not. So that means we need to come up with ways so that we turn this shape into our familiar geometric shapes, okay? Initially, what I did was, okay, this is when I was doing the questions, this is what I did. This is, okay, I have a rectangle, and then I have a good 90-degree right angle isosceles triangle. I said, okay, I did it. Then I started looking at it and says, okay, I don't know how to continue this. So I just had a change of plan. Okay. Then I started thinking like this. Let's first find this value, right? I also have this, right? So what is the value of this? Can you think about it? So this is what we can find, because now if I go and draw this and I draw this as well, okay, this will be again 90 degrees. This will be 45. This will be 45. So the same rules apply. Okay, what did I tell you? If this is, for example, 12, this is 12. This is 12 a square root of 2. Okay, so for the same reason, this one is 12 the square root of 2. I'm going to clean it. So we have this over here. Let me redraw it again. So this is what we have here. So with the same reasoning, can you tell me how long this is? Okay, you repeat the same process. We're going to get this 8 square root of 2. Okay. Now again, we have to find the total area. How? See, this is 45 degrees. And what did I say at the beginning of the video? Okay, because this is 45 degrees, if I go on and draw this, okay, this triangle will be symmetrical, right? Bing. So that means these two are supposed to be equal. Okay, this is very good now. So now I'm going to ask you this. Can you find the total area of this? Okay, remember the formula. You're just going to multiply the base and the height, these two together, and divide them by 2. Okay, so it's going to be 12 a square root of 2 times 12 a square root of 2. Okay, so first we would go on and multiply these two. 12 times 12 is 144. What is the square root of 2 times the square root of 2? It's just 2, okay? Multiply by 2. Remember, we just multiplied them. The formula is a times b divided by 2. So we still have to divide this by 2. So this cancel. So the total area of the purple triangle is 144. Let me go on and write it inside. So 144 is this one. So let's go and repeat the same process. So you could even see it here. Let's just do a comparison. This one, the area was just equal to, if we go on and we multiply 12 by 12, we get this 144. So let's use the same pattern. The area of the green part, the green triangle, like this one, will be 8 times 8. Okay, you could just apply the formula for yourself and see. So the green area is 64. So now I have a question for you. If I go the plus area and I add it to this green area, is it going to be 183? More or less? Let's see. Now if I go 64 and I add it by this 144, if I go on and add them, I'm gonna get 208. But the total area, it says it's 183. How can we explain that? See, do you agree that we overcounted this area? See, when we were finding the purple area, we already counted this part. And when we did the green area, we counted it again. So that's why this one is more. That's why this one is 208, okay? So how do we find this area? It's very easy. If we subtract these two, we're gonna get this. So what is 208 minus 183? It's going to be 25. So the red area here is 25, and we want H. Okay, that's very good. Now, to make things easier to understand, I'm going to go on and draw this red, okay, triangle again. So we know that the total area here is 20, okay, 5. This was a right triangle, okay. So an H, okay, we'll be cutting the area into two parts, okay. So the total one was 25, okay. So what is the area of the half? It's half of 25 is 12.5. So this one is, the shaded part is 12.5. So, and again, we want this H. So, and do you agree that the other part is again equal to H? So this is H. This is also H. Why again? Okay, we're just repeating the same thing because this is 45, this is again 45. So these are actually equal. So this is H, this is H. Let's just repeat the area of triangles one more time. So the height, this H was multiplied by this H. Then we divided it by 2. It became 12.5. So what is this number? So it's easy. You already know it's 5, or we could go H squared is equal to 25. So what is the value of H? It's actually just 5. I think now we know it. It says, okay, it was not really that difficult. And I agree with you, but just coming up with this, like problem 24, probably we are already under stress. Then it would make it more or less a difficult question to do during the test, okay? And finally, problem 25, the most difficult problem of the test. To be able to understand this fully, the only concept that you need to know is combinations. Let's just go and review combinations and then we come back and deal with this question. Let's review combinations real quick. Okay, imagine these 7 letters are the first letter of the name of your friend. So the first one, A, could be me, Ellie, B could be Bob, and then come up with all these friends. And we want to invite 2 of these people over, okay? So how many friends are there? There are 7 friends, okay? And we want to choose 2 friends, okay? So remember, now we use combinations because if I choose A first and D next, or if I choose DA, it's the same thing because we're just choosing 2 friends from 7 friends. It doesn't matter the order, this friend first, this friend, no. Okay, in this case, we use combination, okay? And we'll write it just like that. We're gonna write it as, let me clean this. We have 7 friends. We're going to choose 2. We'll write it as this combination of 7 and 2. And how do we calculate it? We're going to write 7 factorial here, 2 factorial here, and then we're going to subtract them. What is 7 minus 2? 5 factorial. And then we just have to simplify it, okay? So this one by this one is going to be 7 times 6 will be left. And 2 factorials will be 2, okay? So this one 1, this one 3, so the answer is 21. There are 21 ways to just pick 2 friends from 7 friends and just invite them over, okay? And we could apply it to this question. Now in this question, we have 12 seats, right? And we could just assign letters to the seats. So I just have to continue them until I have 12 letters. And then if I ask you choose 2 seats from 12 seats, then you'll go combination of 12 and 2. If I ask you to go and just choose from the 12 seats, okay, choose 4 seats, okay, combination of 12 and 4. And there are 12 seats and we're gonna have 8 passengers. So how many ways can we choose 8 seats for the passengers? Combination of 12 and 8, okay? And just let's review how we do combinations. 12 factorial here, 8 factorial here, 12 minus 8 factorial right here, okay? Now let's go and get back to the question. Okay, now let's go and read the question. A small airplane has 4 rows of seats with 3 seats in each row. 8 passengers have boarded the plane and are distributed randomly among the seats. A married couple is next to board. What is the probability that there will be 2 adjacent seats in the same row for the couple? Okay. So now the story is going to be like this. If you focus on the passengers, you make the question harder than it is, okay? So instead, we're going to focus on the seats. See, a couple will come here, and what do a couple see? They see 8 people are sitting. So how many seats are left? Okay, the couples look, there are 4 seats left. 4 seats are empty, okay? And these empty seats could be randomly. They could be in any possible order. So the couples come, both of them say, okay, they want to sit together, and they see 4 empty seats like this. Can they sit? Of course not. Okay. So now we need to focus on like this. How many seating arrangements are possible? Okay, we reviewed the combinations together. We have 12 seats. Okay, we need to choose 4 of them. How many ways? It's going to be how many ways? Okay. 12 factorial divided by 8 factorial divided by 4 factorial is going to be 495. Okay, you could do it for yourself. So what does that mean? There are 495 ways of selecting 4 seats, okay, for the couple to choose from, right? They come here. It's possible for them to see 495 different arrangements, okay? So now what does the question want? Let's read it again. So a married couple, okay, is next to board, what is the probability there will be two adjacent seats in the same row for them to seat? So we're going to have 495. How many of these arrangements? They have something like this, okay? At least one of this. It could be like two, it's okay. But at least we need like two like this together. So we just need to count the sitting arrangements that have two together. Okay. So one way to do this, probably the easiest way to do this, is going to be like this. You see now, all of these are more than 50%. So that means actually it's quite possible for the couple to be able to sit. So from these 495, okay, more than half of these arrangements will give the couple the chance to sit close to one another. Okay, so what does that mean? It's easier to find the arrangements that are impossible for the couples to sit together. So let's just count those. Like, for example, if the seats are like this, can couples sit together? No. Let's count these. Okay, so from these 495 seats, we're just gonna count the ones that are impossible for the couple to sit together. We're gonna find the impossible ones. This make it easier. This is a complementary approach. Okay. So now let's do that. How we could just find the number of impossible sitting arrangements. Okay, do you agree? We have 4 rows. If in each row there is one seating, okay, then that's impossible. So for example, maybe this one, this one, this one, okay, and this one. As long as there is one seat in each row, impossible for them. So let's count this first. We have 3 seats here, 3 possibilities. Here 3, here 3, here 3. 3 times 3 times 3 times 3, 81. Okay, so first, the impossible ones, that's going to be 81 way. That is impossible for the couples to sit together. Now, is it possible, for example, to have 2 empty seats in one row? So if, for example, empty seat is like this, okay, the couple sit. But if I put them like this, okay, in one row, there are 2 empty seats, but the couple still can't sit together. So maybe it's going to be like this. The next one is going to be something like this. So we have 4 empty seats. What if there are 2 by 2? How many ways is that? Okay. So it's going to be, we have 4 rows. Okay. And we're just going to choose 2 of these rows. Okay. Let's go do that. So for example, imagine this row is A, this row is B, this row is C, this row is D. And we want to choose 2 rows from here. Remember at the beginning of the lesson, we have 4 friends, choose 2. It's the same thing. We just want to choose 2 rows. So I'm going to choose A and C. And then empty seats will be here, empty seats will be here, empty seats will be here, empty seats. So if the arrangement is like that, so the couples cannot sit. Okay. So the next one will be combination of 4 and 2. Choosing 2 rows from 4 rows. 6. So minus 6. There is one more way of counting this. What if we have 2 empty seats in one row, 1 empty seats in another row, and 1 empty seats in another row? That's the final one. We do this, the question's over. So let's do that. I'm going to just choose which of these have 2 empty seats in it. So I'm going to choose a row. So how many ways can I choose a row? 4. Okay. Which one do I like to choose? So for example, I chose this one. Because I chose this one, I'm going to give this this empty seat and empty seat. And then I'm going to choose, how many are left now? There are 3 left, okay? I'm going to choose 2 of these rows, okay? Let's see, and then I'm gonna give them 1 and 1. See, and now I'm gonna just go, for example, I'm gonna, from the last 3 rows, I'm gonna choose 2 from 3 rows. So I'm gonna write it here. I had 3 rows left. I'm just gonna choose 2 of them. Okay, now that I chose it, okay, I could just pick any of these 3 to put E in it, or choose any of these 3 to put A in it. So I have a 3 choice to put. I'm going to choose this one. It's going to get a times by 3. Or I could just choose this one, another one. So the last ones are going to be 3 times 3. So this part probably was the most problematic part to get. Let me review it one more, okay? We had 4 rows, and we're just going to choose one of them, okay? So, and if we choose this one, it's going to get 2 empty seats. Now, we're going to choose 2 more rows, okay? And when we do so, each one is going to get an E. To do that, it's going to be, for example, I'm going to choose these 2. From 3, I'm going to choose 2. Combination of 3 and 2. And now, from these 3, I could choose 1. I choose this one. From this 3, I could choose 1. I could choose this one. Okay, so it's finally over. We just have to multiply this. 4 times 3 times 3 times 3. Okay, so it's going to be 27 times 4. It's going to be 108 ways. Okay, yes. So that's the numbers that are impossible for the couple to sit adjacent. Okay, let's go and find it. This will be actually, these 2 together will be 87. So together is going to be 195 seating arrangements. The total one was 495. 195 of them are impossible for the couple to sit together. So we're just going to go and subtract this. What is 495 minus 195? Okay, is going to be 300. So all we really need to do is simplify 300 and 495. So we could simplify them by 5 at first. It's going to be 60. Okay, it's going to be 99. Okay, again, I'm going to simplify it by another 3. It's going to be 20 over 33. So the answer will be C to this question. So the way I did it, it was not easy to understand. It was not easy to do. So probably there are easier ways and there are easier solutions for this question. This is the first one. Once I find something easier, I will upload another video and I'll explain the question one more time.